Okay, let's talk about how we deal with significant figures in calculations. Okay, so there are two sets of rules for dealing with significant figures in calculations. One has to do with significant figures with multiplication and division. This is the one that we will use by far most of the time. Most of the calculations that we'll be doing in this course will be involving multiplication and division. The other set of rules are for when you are doing addition and subtraction. We will use this, but much less frequently. So let's look at the rules. So the rules for how many significant figures your answer should have when you are doing multiplication and division is that the fewest number of significant figures in the problem will dictate the number of significant figures in your answer. So your answer should have as many significant figures as the fewest number of significant figures in the problem. I'll say word problem. Okay, so another thing to pay attention to here is that exact numbers do not contribute to significant figures. Only measured numbers. So we're only looking at the measured numbers. Only measured numbers. So these are numbers that have units after them. We haven't talked about conversion factors yet, but when we get to conversion factors, we're going to see that conversion factors are exact numbers. So the number of significant figures in a conversion factor also do not contribute to the number of significant figures. I'll remind you of all of that when we get to a specific example. Okay, so this is true for both cases. Exact numbers do not contribute to significant figures. What I mean by an exact number is like if there were 10 students in the room, that's an exact number because I counted 10 and it's not measured. So we don't need to worry about accuracy and precision because we know there are 10 there. When we're talking about something that we're measuring with a tool like meters or a scale and we measure how many grams something is, that's when we need to worry about significant figures. Okay, so here let's look at a problem. Let's say, what is the average mass of a piece of metal weighing 35.7 grams, 34.999 grams, and 34.82 grams. So let's just say you have a piece of metal in the lab and there's 3 different scales at the front of the lab and you weigh it 3 different times on 3 different scales. And these scales all have various levels of precision. Like this one goes 1 decimal place, this one goes 3 decimal places, this one goes 2 decimal places. So you want to know what's the average mass of this piece of metal. So the way you take an average is you add up the number of samples you have and you divide by that number. So to get the average, I'm going to say 35.7 grams plus 34.999 grams plus 34.82 grams, and I'm going to divide by 3. So this is kind of a tricky example because there is both addition and division in this problem. The rule for significant figures always depends on what the last step was. So by order of operation, calculating an average, the last thing that we're doing is dividing, so that means we follow these rules. So I'm just going to plug this into my calculator. Let's say 35.7 plus 34.999 plus 34.82 equals 105 point whatever. And I'm going to divide by 3. So I'm just going to write this whole number out. The average equals 35.173000000. Okay, grams. So if you answered this on an exam, you would lose a point, because even though this is the right number, and even though you have the correct unit, this is not the correct number of significant figures. So let's figure out how many significant figures this answer should have, because it doesn't say report your answer to a certain number of significant figures. You determine how many significant figures your answer should have based on the problem. So here I have 3 different masses. This mass has 3 significant figures. This mass has 5 significant figures. And this mass has 4 significant figures. The question says for multiplication and division, your answer should have as many significant figures as the fewest number of significant figures in the word problem. Fewest. So 3 significant figures is the fewest number of significant figures. So that means my answer cannot be more precise than this measurement, because this is the least precise. So my answer can't be more precise than that. So 3 significant figures is how many I need. 1, 2, 3, and then I look at the number after it. This number is higher than 5, so I'm going to round up. So the answer to this question is 35.2 grams. That is the answer. This is the answer that would get you all of the points if this was on an exam. Your math needs to be correct. Your significant figures need to be correct, and your unit needs to be correct. There's always 3 pieces, at least, to a correct answer when we are doing calculations in chemistry. So again, this was multiplication and division. The number of significant figures is the fewest number of significant figures in the problem. Measured numbers. So now let's do an example with addition and subtraction. So let's say you have 3 books in your backpack. Whoops, I should write before I write the problem, let's write the rule. The rule says your answer should have the fewest decimal places. Your answer should have as many decimal places as the fewest decimal places in the word problem. Fewest decimal places, not fewest significant figures for addition and subtraction. So I'll write out the problem. Okay, so it says you have 3 books in your backpack. One weighs 5.765 pounds, one weighs 7.50 pounds, and one weighs 1.576 pounds. What is the total weight of your books? So I am going to add these 3 masses together. 5.675 pounds plus 7.50 pounds plus 1.576 pounds equals, so let's just say 5.675 plus 7.50 plus 1.576 equals 14.751000. Okay, that's how many pounds of books are in the backpack. So again, if you answered this on an exam, you would lose a point because the math is right, the unit is right, the significant figures are not. So again, let's see how many significant figures should we have. We should have the fewest number of decimal places in the word problem. So this has 3 decimal places. This has 2 decimal places. This has 3 decimal places. So that means my answer should have 2 decimal places. So I look here, 1, 2. This is the number of decimal places I should have. Again, I always look next to see if I need to round up or just drop it. So the correct answer here is 14.75 pounds. So one thing that I want to mention is that we didn't use 3 at all in the calculation because 3 books is not a measured number. 3 books is an exact number. An exact number is something that you count. A measured number is something that you use some sort of measuring device to measure, like pounds, mass, length, anything like that. So that's why 3 having 0 decimal places didn't come into play at all. So again, we will not do a lot of addition and subtraction examples when we are doing a lot of the calculations for chemistry, but it is still important that you know this rule. Most of the calculations that we will be doing will be multiplication and division, and you always use the fewest number of significant figures in the word problem. So it won't tell you in the problem how many significant figures to use directly. You will need to look at each of the numbers, identify how many significant figures are in each of the numbers, and then make sure you report that number, your answer, with the correct number of significant figures.